Good morning. I'm Navneet Kaur, lecturer in IT department from GPC Amritsar. Today I'm giving the lecture on the topic of Introduction to TCP IP. First of all, the contents of today's lecture. First, I'll explain the introduction to TCP IP. Then the different concepts of the addressing, in which I explain the concept of physical addressing and logical addressing. Then the different classes which is available in IP addressing, subnetting and supernetting. Then one concept is used, that is the loopback concept. Again that I'll explain the IPv4 packet format and what is the requirement of IPv6, and at the last I'll explain the different protocol suites. Before starting the lecture on TCP IP, you must know about the OSI model. As we all know, OSI model is the layered network model. It is the standard given by the International Standard Organization, that is ISO, that covers all the aspects of network communication, is the open system interconnection model. There are the two type of systems. One is the open system and another is the closed system. Closed system means in which only the similar type of systems can communicate. But if we want to communicate the different type of systems, then we have to use the open system. So an open system is the model that allows any two different systems to communicate with each other. In OSI model, we have 7 separate, which are different layers, but they are related to each other, and each of which define a segment of the process of moving information across the network. These are the 7 layers of OSI model. So it is called the layered architecture. In this, the first layer is the physical layer, second is data link layer, next is the network layer, then transport layer, session layer, presentation layer, and application layer. These layers are different, but they are related to each other by using some interface or by using some protocols. So these layers have their own responsibilities and they perform their own work. Now the brief introduction of the responsibilities of the different layers. In the physical layer, as the name, it is the physical layer, so it will use the bits to transmit the bits over the media. We concern about the physical topology, we concern about the encoding. So all these type of concepts are included in the physical layer, so it provides the mechanical and electrical specification. Second layer is the data link layer. So to organize the data, that is the bit information, into the frames, that is we add header and we can add the trailer on this, that is we can organize the information, bits information, into the frame in the data link layer. Next is the network layer. In the network layer, we have to concern about the packets. We have to route the packets from source to destination. So it is basically to provide the internetworking. Next layer is the transport layer. Transport layer is basically used to transmit reliably process to process message delivery and error recovery. Process to process means we concern about the particular process which is running on one machine to the particular process that is running on the another machine. Next layer is the session layer. It is used to establish, manage and terminate the sessions. Presentation layer is basically concerned when we require some security concept, that is we have to encrypt the data, we have to translate, we have to compress the information on the sender side. So the reverse process is performed on the receiver end so that we can get the original information which is sent by the sender. Last is the application layer, which allow the access to the network resources, because the application layer is the layer where user is directly interacted with the model. So this is the only a framework, it is only a theoretical concept which is basically used to invent the another protocol models, that is TCP IP. Now the introduction to TCP IP. TCP IP stands for Transmission Control Protocol and the IP is Internet Protocol. So TCP IP is the set of protocols that defines how the transmission takes place as well as exchanged across the Internet. TCP IP Internet operates like a single network connecting many computer of any size and any type. So in this we are using the computer systems which of any size and any type, and they can communicate with by using the TCP IP. Now we can compare OSI reference model with the TCP IP model layer. As we all know, in the OSI model we have the 7 layers. And when we comparing these layers with the TCP IP protocol suite, so the first two layers of OSI model, that is the physical and data link layer, combinedly use some underlying LAN and WAN technology. So in the TCP IP protocol, the physical layer and data link layer use the underlying LAN and WAN technologies. The network layer OSI model is the same as the network layer in present in the TCP IP protocol suite, but in case of TCP IP protocol suite, we using IP protocol for routing the packets from source to the destination. So the main protocol which is used in the network layer is the IP protocol. For supporting the IP protocol so that the reliable communication can be done, so we have some helping protocols which used for the packet to route the reliably from source to the destination. Next layer is the transport layer, which is same as the OSI model in the TCP IP protocol suite. This transport layer use the several protocols. We can use TCP, UDP, SCTP protocols for the transmission. The last three layers, that is session, presentation and application layer of OSI model, is combinedly known as the application layer in case of TCP IP protocol. In the TCP IP protocol suite, several application protocols can be used at the application layer. Now the some facilities which is provided by the TCP IP, so that's why we use the TCP IP. So some common facilities which is provided by the TCP IP, first is the stream data transfer, then the reliability, flow control, multiplexing, logical connections and full duplex. Now I'm explaining one by one these facilities. First is stream data transfer. TCP transfer continuous stream of bytes. So TCP does this by grouping the number of bytes in the TCP segment. We simply organize the stream of bytes into the some segments and we transmit those segments to the destination. So which are passed to the IP for the transmission to the destination. So TCP can transmit the data information in the form of segments. Reliability. The main feature of TCP is it is the reliable protocol. Why it is reliable? Because it is using the concept of acknowledgement. TCP assign a sequence number to each byte which is transmitted and expect a positive acknowledgement from the receiving TCP. So if the acknowledgement is not received within that particular time unit, that means data is lost during the transmission and we have to transmit that particular sequence number data again. So this means TCP is reliable and data is not lost. If it is lost, that means we can easily transmit that information again. Next is the flow control. The receiving TCP when sending an acknowledgement back to the sender also indicates to the sender that how many number of bytes it received and beyond the last received TCP segment without causing any overrun and overflow in its buffer. By using the acknowledgement and the sequence number, we simply know how much information is received by the receiver. So we can easily manage these information without causing any overrun and overflow. Next is the multiplexing. Multiplexing means to allow the many processors within the single host to use TCP communication facilities simultaneously. The TCP provides the set of addresses within each host, that means multiplexing. Next is the logical connection. TCP initializes and maintains the certain status information for each data stream. The combination of this status include the sockets, sequence numbers and the window size, which is called the logical connection. So each connection is uniquely identified by the pair of sockets which is used by the sending and receiving process. So in the TCP, we simply organize the information by using some logical connection which is include the socket, sequence numbers and the window size. Last is the full duplex. As we all know, there are the three type of transmission modes: simplex, half duplex and full duplex. In simplex, only sender can send the information and receiver can receive. But in half duplex, both can send and receive the information but not at the same time. But TCP provide the concurrent data stream in the both directions. So sender and receiver both can send and receive the information at the same time. Now next topic is TCP IP protocol suite. TCP/IP is the hierarchical protocol made up of interacting modules, each of which provides a specific functionality, but they are not necessarily interdependent. So, the term hierarchical means that each upper level protocol is supported by one or more lower level protocols. So, TCP/IP is the hierarchical protocol. Hierarchical protocol means every upper level protocol is supported by one or more lower level protocols. This is the diagram of TCP/IP protocols here. In this diagram, clearly define the each protocol which is used in the TCP/IP protocol suite. The physical layer and the data link layer combinedly use the protocol which is defined by the underlying network, that is host through network. Next layer is the network layer, which is also called the internet layer. The main protocol which is used on the network layer is the IP, that is inter-network protocol. So, it is basically used for the internetworking. By using this IP, we can simply route the packets from source to the destination. For this IP, we have some supporting protocols. First is ICMP, that is Internet Control Message Protocol, IGMP, that is Internet Group Message Protocol, Address Resolution Protocol, and Reverse Address Resolution Protocol. In case of transport layer, we basically use two protocols, that is TCP and UDP, that is Transmission Control Protocol and User Datagram Protocol. Stream Control Transmission Protocol is also used in the transport layer. The last three layers, which is combinedly known as the application layer, in case of TCP/IP, uses the several application protocols. It is basically used according to the requirement of the user. If suppose they want to send the mail, it simply use the SMTP protocol, that is Simple Mail Transfer Protocol. So, depend upon the user's requirement, we can select the protocols from these protocols. So, at the application layer, we have the several protocols. So, this is the diagram of TCP/IP protocol suite in which the different collections of protocols are shown. Now, I am explaining the different layers of TCP/IP. So, first of all, the two layers, that is physical and data link layer. At the physical layer and data link layer, TCP does not define any specific protocol. It supports all the standard protocols which is using in for the underlining the LAN and WAN protocols. So, the network in the TCP/IP internetwork can be local area network or the wide area network. Next layer is the network layer. In the network layer, the main protocol which is used to route the packets from source to the destination is IP. So, IP is basically used for internetworking. IP uses for another supporting protocols, that is ARP, RARP, ICMP and IGMP. The full forms of these protocols: IP is the Internet Working Protocol, ARP Address Resolution Protocol. Address Resolution Protocol is basically used when we convert the IP address to the physical address. So, if we want the IP address from the physical address, we use the Reverse Address Resolution Protocol, which convert the physical address to the IP address. Next is the Internet Control Message Protocol, that is ICMP, and then IGMP, that is Internet Group Message Protocol. Now, I am explaining these protocols one by one. First of all, the Internet Working Protocol, that is IP. It is an unreliable and connectionless datagram protocol. It is the best effort delivery service. Best effort means that IP provides no error checking or tracking. So, IP assumes that unreliability of underlying layers and does it best to guide the transmission through its destination. So, IP is basically used to route the packets from source to the destination. For these routing purpose, we use some supporting protocols. So, first protocol which is supported by the IP, that is Address Resolution Protocol. Address Resolution Protocol associated an IP address with the physical address. By using this ARP, it is basically used to find the physical address of a node when we know IP address of that node. Means if we know the internet address, we can simply find out the physical address of that node by using the ARP protocol. If the reverse process we have to use, that is Reverse Address Resolution Protocol, it allows host to discover its internet address when it's know only it's the physical address. A server on the network recognizes the ARRP packets and returns that host internet address. So these are the conversion protocols. Next two protocols is the first is ICMP, that is Internet Control Message Protocol. The ICMP is the mechanism which is used by the host and the routers to send the notification of datagram problems back to the sender. If there is some problem in the notification, that notification is sent by the ICMP, which is send the notification back to the sender. Last supporting protocol is IGMP, that is Internet Group Message Protocol. It is involved the two types of communication, unicasting and multicasting. So unicasting means one to one and multicasting means one to many. So it what type of communication is done is controlled by the IGMP. Next layer of the TCP IP protocol suite is the transport layer. In the transport layer, the basically two protocols are used, that is TCP and UDP. TCP is transmission control protocol and user datagram protocol is the UDP. TCP and UDP are the transport level protocols which is responsible for the delivery of message, that is the one process running on the one computer system to the another process which is running on the another computer system. As we all know, the computer system have the several processes running. So we concern about the particular process which is running on the one computer system to the delivery of message to the another computer system. On the another computers again the several programs are running, so we concern about the particular process to process transmission. So that is only possible by using TCP and UDP. One another supporting protocol is used on the transport layer, that is the SCTP, that is Stream Control Transmission Protocol. The last layer is the application layer. The application layer in the TCP IP is equivalent to combine the session, presentation and the application layers in OSI model. In the application layer, there are many protocols which are defined. We can use those protocols according to the requirement. Requirement is depend upon what type of information that user want to send from sender to the destination. So it depends upon which type of protocol is used, is depend upon the user's requirement. After the TCP IP protocol suite, the main topic is different type of addressing. Now first question is arises, what is addressing? TCP IP uses the 32 bits or 4 numbers between 0 to 255 to address a particular computer system on the network. Suppose when an application wants to set up a connection to another application, it needs the address of that particular computer system. What type of connection you are using, that is it can be a connection oriented service or it can be connectionless, but basically it required the address of source and destination points. So what kind of communication or services used doesn't matter, we have to know the address of source and destination points. So in the internet, these endpoints are always paired in the with the IP address and the local port address. So we have the basically two type of addressing, that is the physical addressing and the logical addressing. So we can divide the addressing into two type, that is physical addressing and the logical addressing. Now what is the physical addressing? Physical addressing is the NIC, that is network interface card number, that is given by the original manufacturer or the network administrator. So each network interface has a MAC address, that is media access controller. It is also known as the physical address. This is the actual hardware address, that is the lowest level of network user to communicate. This is only by using this physical address we can only communicate within the small network. It is the lowest level of the network that user can use and communicate. So this address is basically assigned to the network interface card by the original manufacturer or by the network administrator. So physical address is the MAC address. Physical addresses, format of physical addresses depends upon the what type of a network we are using. So there are the three type of physical addresses which is using. First is unicast, second is multicast, third is the broadcast. First is unicast address. These kinds of addresses are permanently assigned to the network interface card and unique for each machine. So unicast means one single host. So this card monitors the transmission and matches them against this address to identify the frames assigned to it. This monitoring helps the host, and it is basically used to transmit the information to specific network device on the network. So unicast is the address which is used by the single host. Now second address type of physical addressing is the multicast address. Multicast addresses are given to the group of hosts instead of the single host. Single host in the case of unicast. So there's to receive a datagram, they identify a group of stations or machines which is present on the same domain. So the computer, host computer which set the NIC to accept the specific multicast address. This addressing technique is very effective if the common information is to be communicated to a group of hosts. If we want to send the common information to a particular group or particular domain, we can use the multicasting address. Last type of physical addressing is the broadcast address. It allows the information to be sent to all the computers which are present on the subnet rather than on the particular machine. So broadcast directed the packets to the received by each and every machine which is present on the subnet. Now next is the logical addressing. To provide a unique identifier for the specific node on the network by the network operating system is called the logical addressing. The network operating system establishes the logical addresses for the different nodes which are present on the network. So logical addressing is the one which defines the logical topology which is used by the host to reach the particular host on the network. Now the main topic is the IP addressing. IP addressing is the internet protocol address which is a unique identifier for the node or the host on the particular IP network. IP address is basically the 32-bit binary number which is represented by the 4 decimal values, and each decimal value is represented by the 1 byte which means the 8-bit, and in the range of 0 to 255, and these are separated by the decimal point. So that's why it is known as the dotted decimal notation. For example, here the address is 140.179.220.200. So these are the IP address which is total of the 32-bit binary number, and it is represented by the 4 decimal values, different 4 decimal values, and each value is represented by the one single byte, and which is of 8-bit, and it ranges from 0 to 255. So that's why it is called the dotted decimal notation. Now the classful IP addressing. Systems that have interfaces to more than one network require a unique IP address for each network interface. There are the two hierarchical level addressing. First part of the internet address is identify the network on which the particular host is present, while the second part is identify the particular host which is present on that given network. So the two level addressing hierarchy is represented by the two parts. First part is the network number which is given give the particular network ID on which the host is present, and second is the host number which define the particular host which is present on that network. Now the different classes of IP addressing. Why we require the different classes in case of IP addressing? Basically we have to support the network of vary size. So designer decide that IP address space should be divided into the different classes. So they divide that into the 5 classes, which is class A, B, C, D and E. Now the this diagram shows the reserved bit of different classes. So there are the 4 bytes each of 8 bits. So in case of class A, the first bit of the first byte is reserved as the 0. In case of B class, the 2 bits of the first byte is reserved as are the reserved bits. So in case of class B, 1, 0 are the reserved bits of the first byte. In case of class C, the first 3 bits, that is 1, 1, 0 are reserved of the first byte. In case of class D, the 4 bits, that is 1, 1, 1, 0 and in case of class E, the 4 bits that is 1111 of the first byte are reserved. So this diagram shows the reserved bits of the different classes of IP addressing. This diagram shows how many number of bytes is used to identify the network ID and how many number of bytes is used to identify the host ID. As we all know, in the previous diagram, the first bit of the first byte is reserved as 0 in case of class A. So first byte, that is the 1 byte, is used to identify the network ID, and the rest of the 3 bytes are used to identify the host ID in case of class A. In case of class B, the first 2 bits of the first byte are reserved as 10. So the 2 bytes are used for network ID, and rest of the 2 bytes are used for the host ID. In case of class C, the 3 bits are reserved, that is 110, and the 3 bytes are used to identify the network ID, and only the 1 byte is used to identify the host ID. In case of class D, we using the special address, that is the multicast addressing, and in case of class E, we reserve that class E for the future use. So this is the diagram which is show how many number of bytes are used to identify the network ID and how many number of bytes are used to identify the host ID. Upon the basis of these, we can define the different ranges of the classes. We simply say that the number of bytes are there, so we can use the word octet. So this is the binary notation which is show the reserved bits and how many number of bytes are used in the different classes. Now the different ranges which show in the different classes. So first of all, the class A, it ranges from 0 to 127. In case of class B, it ranges from 128 to 191. In case of class C, it ranges from 192 to 223, and in case of class D, it ranges from 224 to 239, and in case of class E, it is ranges from the 240 to 255. Now it is the daughter decimal notation. This is the binary notation which is given. We simply can derive these from the that daughter decimal notation. Here the number of binary represented, so we simply use the 2 raised to power 8, which is 128. In case of this, it becomes 11. In case of this, 2 raised to power 0, 2 raised to power 1, that means 2 plus 1 equals to equivalent to the 3. So this is the daughter decimal notation. From this, it ranges from the 127 to 191, that means it belongs to the class B address. So in case of class B address, the first 2 bytes are used to identify the network ID, and rest of the 2 bytes are used for the host ID. Now the two processes are used, that is subnetting and supernetting. Subnetting is the process of breaking down an IP network into the smaller subnetwork, which is called the subnetworks. Simply we using 128.10.00, so it belongs to class B. We simply use this the rest of last of the 2 bytes for the host ID. Because of the first 2 bytes are used for the network ID, we arrange this into the 2 subnetworks. One is 1.1 and 1.2, so on, and another is 2.1 and 2.2, and so on. So that particular address is divided into the 2 subnetworks. Now the supernetting, it is exactly opposite to the concept of subnetting. In the subnetting, the network address is split up into the number of subnetworks to organize them. So the subnetting is needed in case of class A and B, because in case of class A and B, we have in case of class A, we have 3 bytes used to host ID, and in case of class B, we have 2 bytes used for the host ID. Now the concept of supernetting is implemented in the class C address, which is basically used for combining the different addresses. Supernetting, when a company is the large enough and it is required the host far more than the maximum limit which is supported by class C network. This problem can be solved by the process of supernetting. That means if the organization combine the number of classes C or networks to generate one bigger network. Suppose we required, that organization required 1000 host address. It can simply have 4 class C network blocks to combine that, because in case of class C we have only one byte which is used for the host ID. Next is the loopback concept. Loopback concept is basically used for the testing purpose. We simply want to check the network whether it is properly working or not. We simply use this loopback testing. So it is the powerful concept for fault isolation in the network. So the loopback testing circuit allow performing a loop